of any microcontroller or embedded system to control the different parts, different electromechanical devices, uh, the actuators on the basis of the input from the sensor. So sensor is the input part of the embedded controller and the actuators is the output part. The function of the actuators to move something or take the necessary action, and these are the control. Actually this control uh, is done by this controller, and the power is general requirement, the power source is the general requirements, and the user can also communicates with this through the controller. So the controller is the heart of any system. It consists of hardware and software part. So look at that, what is the microcontroller. In our previous class, in our BTech also, we learn about the 8085 microprocessor. The microprocessor and the microcontrollers action near about same. The only difference is that uh, the microcontroller is prepared for small action, small system controller, because it's integrate with the memory parts, other peripheral controllers in a single chip. Whereas in microprocessor, that chips are different, so it become the large size. So microcontroller is basically a single chip devices, you may say, as a standalone system. The only requirement is to connect the oscillators, uh, basically the crystal oscillators, which provide the clock pulse and the external power supplies. In other system also, some push-pull amplifiers is required, and similarly for increased current, Darlington pair transistor is required to provide the additional current, because the drawing power and the source power, means the microcontroller send the less amount of current and sink less amount of current, though the amount of sinking current is greater than the amount of the delivered current, means that it provide a less amount of current in near about the milliamperes. uh, so this amount of current is not able to drive any motor, because the requirement for motor is huge, near about the 1 ampere, 1.5 amperes, and so more. So this much of amount of current not able to not sufficient to drive that type of motor. So the additional circuits are required. So look at this system. We know that in any microcontroller there are two part. One part is hardware and other part is software. So the basic function of hardware to make the communications part, and uh, it acts as the interface between the input and output, and it try to execute the program. So look at the system. There is a program, then memory, central processing unit or CPU, and the clock. So clock is coming from the crystal, and look at this side are the input side, and this side the output side. So the inputs are switch, keyboard, other sensor here, different types of sensor you can use. So these sides for the input side, and this is for the output, where you can connect the different kinds of output. So this is the uh, overall block. And look at, I already mentioned that uh, these buses are connected to the different unit. The program memory unit, the function of program memory unit to store the different commands, okay, different instructions here, and for execute the instruction you require the data memory. The data are required, and these data are fetched from the data memory. So program memory and data memory. Then after the execution you do some tasks like the on off type system, like on your uh, light, on your fan, off your fan, on your motor, off your motor, like that. So these are the IO and the peripherals. So all are connected with central processing unit, that is CPU, and every function every function operated on that basis depending on the clock. So if you consider any type of microcontroller and microprocessor, every operations are performed in the accumulator. We already discussed about the accumulators. Now the Atmega 328, which are this is a common name. Atmega 328 is the basic microcontroller, and this is actually called the Arduino, and it get the huge popularities because
Yes, sir.
okay. So look at the Arduino pin diagram. If you think that Is it visible? Is it visible?
Yes, sir. Yes.
What is written here?
And sir, it's opposite HTML.
Hmm. Then at the right side,
1132. HTML GA3268 PU.
at mega, ATMEGA, at mega.
Okay, sir. 8 mega 32
Uh,
8 PU.
so at mega 328. So you can identify that chip and look at these are the pin. These are the pin for Atmega, that is Arduino. So this board is developed. We called it Arduino Uno board. This is a mini uh, board, and this board have this type of pin. Look at, first I call the ground pin. So this pin is ground pin. This pin is transmitter, and this pin for receiver. So ground, transmitter and receiver. Transmitter means uh, you can send a signal through this board to other, and receiver means you can receive the in starting signal or the interrupt signal from the transmitter pin, receiving pin. It's basically used to communicate with the other devices. Suppose before starting my lecture, I ask you that my voice is audible or not. So this is not the part of your lecture. This part I basically used that I start to communicate something with you, and you are ready, but due to the channel, means the medium where I try to communicate with you is faulty, or there's some error. So before delivering my lecture, I check everything. The similar function of the transmitter and the receiver. The transmitter of this system is connected to the receiver of the other part, and the receiver part of that system is connected to the transmitter part, means the cross connection. The one transmitter is connected to the other receiver, and the other receiver connected to its transmitter. So it's basically the cross connection. Now ground, transmitter, receiver part is over. So look at there, the this is the power supply unit, power 5 volt on 3.3 volt, ground, and the V in. So this is basically the power to satisfy the different power requirement of different ports, and others to make the common ground or isolated ground. You can use this pin also. You know that the microcontroller uh, is basically provide a signal. This signal is depends on the system, basically the 5 volt. So 5 volt means we measure this voltage with a reference 230 and 235, the difference is 5 volt. 100 and 105, the difference is also 5 volt. So we measure this 5 volt with a reference, and this reference is ground. The ground is basically is the common for both input and output. So why the ground is common? Because the reference voltage which we supply with respect to a common reference. Otherwise, not understood that it is 5 volt or 1 volt or 0 volt, something like that. So the common ground is highly important for the system as well as the microcontroller, here Arduino. The reset pin, to using this pin you can reset your program, and this is the IO reference pins. The name suggests that its function. So look at, there are few analog input A0, A1, A2, A3, A4, A5, means 6 analog input. Here you can send the analog signal to the Arduino. So we know that the microcontroller is basically perform the operation the digit base, means 0, 1, based on that. So obviously the ADC is included inside the chip. So analog input is converted to digital part, digital input. So look at these 6 analog input are connected to Atmega 328 IC. Now these are the general purpose pin. Look at 7, 8, 12, 13. You can program the all pin, and it's called the PWM, this signal. Look at this signal you can find at the in your computer keyboard also, just below the escape keyboard. So this symbol is basically indicate the PWM signal. PWM is pulse with the modulation signal. These signals is very much important because it provides the input for Arduino, for motor control through the Arduino. So using this signal you may control the speed of motor. You know that in any digital signals there are some on time and off time. So if you increase the on time, means the 5 volt, for example, I use this pen. So look at this signal. So this is actually the PWM signal. You may increase or decrease its width. So this is actually the on time and this is the off time. And you know that the duty cycle, you already know that the duty cycle. So if you increase the turn on time, means the average 5 volt is high. If you increase the turn off time, then the average 5 volt is less. Means you deliver the turn on time to a motor high with respect to turn off time of the another point. So obviously the speed is increased with respect to the other motor. So in this way you can control the speed of a motor. So PWM signals are basically used so PWM signals are basically used to control the motor speed. So I hope that the all points of the Arduino output is clear to you. So look at this board. There is a pin, the same pin of the reset pin. So look at that the AVR CPU is basically the functions of the different part we discuss about one by one. So look at the ports. The ports are here. Port C, port B, port D. So port C consists of 7 pin, port B consists of 8 pin, and port D consists of 8 pins. The total pin, how many pins are there? Count. So come here into the chip. So port C 0 to 5 means the total 6 pin here, and this consists of ADC, analog to digital converter. So these port are basically the port C, and it consists of 6 pin P0 to P5, and it contains to the pin number is there. So these port are basically ADC pin. So ADC means it use the analog input. Now look at the other pins. So this portion is PD, D port, PB, and the PD also here. So it's not a systematic manner. In 8051, the all pins are in systematic manner. Though it is not in a systematic manner, but it tactfully make arrangement here. Okay, so these pins are arrangement the external, but internal pin diagram is different. So we make it our as per our requirement. So these are the ports: port D, port B, and the port C. So I hope that you know that USRT is already known to you. Everything is similar with the micro processor, but it is in a small scale. Now, so I hope that you go through that the features of ATmega. It is the high performance, low power AVR 8-bit microcontroller. So basically the Atmega 328, the pins ICs, these board are basically the AVR microcontroller. 8-bit means it able to process 8-bit data at a time, and it's based on the RISC architecture. The full form of RISC is Reduce Instruction Set Computer, RISC architecture. Okay, means the instructions are basically a compact instructions, and it generally complete in a one clock cycle execution. So due to the single clock cycle execution, its execution time also less. It has 32 into 8 general purpose working register. It's fully static operation, and it provides the 20 megahertz clock speed operation. It provides the 20 MIPS throughput. It is a huge throughput. Look at these different features are basically tell us its extensibility of the program. So look at the in-system self-programming fast memory is different 4, 6, 16 and 32K. It available into 4K bytes for small operation, 6K byte and 32 kilobyte the maximum. So flash program memory are basically used to store the your program, means which you burn, it stored into the flash program memory. There are EPROM also there, and its size maximum 1 kilobyte, and the internal SRAM is 512 or 1K or 2K bytes, the static RAM. So you just go through this. Now the most important part is peripheral features, and I request all of you to remember these features, the peripheral features, because this is the most important part. It's required to programming of the microcontroller. It has two 8-bit timer and counter, timer or counter. We discuss about details of timer and counter in our next session. So the timer and the counter is 8-bit, mean is starting from 0 0 0 0, that is the 80 to 1111 81. So 80 to 81 means FF 0 to FF. So it able to count, and one 16-bit timer and counter separate prescaler and compare mode and capture mode. So look at the 8-bit timer, prescaler compare mode is fine, but not able to capture something. But 16-bit timer able to capture. So there are three timers: the 8-bit timer or counter, 2 number, and one 16-bit timer or counter, and both able to perform counting, either counting or timing purpose. So if you think about the timer, look at I just show you. The function of timer means in every clock pulse. Look at, this is the clock pulse. Okay, the age. So 1, 2, 3. The function of counter, it count that how many times age are repeated. Means here 1, 2, 3. So it count 3. But when you talk about clock, means it related with the external clock. Means based on the clock, it provide the timing. Means after 1 millisecond you turn on the LED. So how it count the 1 millisecond? So the 1 millisecond it count with reference of its external crystal oscillator. So the external crystal oscillator is considered as the reference clock. So the timer and counter is the two different part. One, counter is count how many edges appear, and for timer it just simply calculate that timing. So both the timer and the counter are necessarily required to perform any automatic system. Suppose that if you turn on a switch and you state that after turn on this switch the motor will run after 5 seconds. So after 5 seconds these tasks performed by the timer. And another program you say that after blinking LED 5 times its buzzer will run. So 5 times. So the counter, here the counter will activate and it count that how many times the LEDs goes high. How? By measuring the edge, either positive edge or negative edge, we able to count the high and low. The another is the real-time counter. So total 4 counter we observe here, 2 8-bit, 1 16-bit, and the one real-time counter. There are 6 PWM channels. So this channel 3, 5, 6, 9, 10 and 11, there are 6 PWM channel. So using this 6 PWM channel, you able to control maximum 6 motor using the inbuilt PWM channel. Eight channel 10-bit ADC, 6 channel 10-bit ADC for different package, programmable serial USRT, master slave SPI, that is serial interface, byte oriented two-wire serial interface for I2C communications. Details we learn later. Programmable watchdog timer and separate on-chip oscillator. On-chip analog comparator, interrupt and wake up on pinches. So these are the datasheet of Atmega. The special microcontroller features the power on, reset and programmable burnout detection, internal calibrated oscillators, because you know that the every input output is based on the clock, and so the clock frequency is coming from the oscillators. So if the oscillator frequency is changed or varies, then the synchronization is not possible. Synchronization for different microcontrollers is not possible. So the calibration is required, and the internal calibrated oscillator provide that. External and internal interrupt sources. For a good microcontroller, the interrupt source and interrupt service routine is essential, a requirement. And the 6 sleep modes: idle, ADC, noise reduction, power save, power down, standby and extended standby. The I/O package maybe 23 programmable I/O lines, 28 pins, 32 lead TQFP pins. These are all the things. Look at the power consumption. Active mode only 0.2 milliampere. Okay, so very less, 0.2 milliampere, and power down mode is 0.1 microampere, and the power save mode is 0.75 microampere. So few, very less amount of power it consumes. So the advantage of Atmega, that if you use the Atmega, it draw the less amount of power, which is essentially required for battery operated system. That is the standalone system you can use in the power save mode, which consume only 0.75 microampere, and the power down mode it's only 0.1 microampere. Look at there is a difference, 0.2 milliampere and 0.1 microamperes. There is a huge difference in power down mode. It draw the less amount of power. So look at the different pins which I already discussed with you. These pins are called digital pin headers. This is Atmega 328 MCU. This is inbuilt LED which is connected to 13 pin. So in different example of Arduino program, you observe that a starting program is considered using pin number 13 because it has inbuilt LED. You can test the board using that LED pin also. So these pins are we already discussed. This point is reset button. Sometimes it may be here. This is the USB connector, and this is called the barrel jack. One important thing is that Arduino program is the open source program, means you are allowed to copy the program. Why? Since it is an open source program, so that you can develop or you can improve by using the source code. So this is the advantage. Similarly, the Linux is also the open source because the developers, you with the help of the other program, you may improve this program overall. This is Arduino R3. Look at the reset button is here. Here the Atmega 16 U2 replaced by FT23 RL for USB serial communication. The next is Arduino Duo. It is actually 32-bit ARM Cortex M3 architecture. ARM Cortex M3 architecture, and look at here the number of pin is shown here 53. A huge number of input output pins, so you can use it you can use for different applications. And here the voltage, operating voltage is 3.3 volt. So the few functions are the same. Look at the here the PWM, this channel all are PWM 2 to 13, all are PWM. Means how many pins? 1 2 3 4 5 6 7 8 9 10 11 12. So 12 PWM pins are there. And look at the transmission and receiving pair. So there are 0 to 3, means the 4 transmission and receiving pair. So you can communicate with 4 different devices. Here ADC, DAC are available, and look at for these digital pins. So these are digital IO pin. So this is the differentiation. This is the sketch of Arduino. You may in your off time you may look that sketch. And this is the different pin for Atmega 328. I just skip, those are not required for our course. So this is the just for information. These pins are used separately, and these are the bidirectional, means the both input and output you can use as per your requirement. So when you want to take the information from the external, then we called the into microcontroller. So this is the input. So the input means the information which we want to receive from the external sources. Output means when we want to change the state of something, like the on and off of any system, then we call it the output system of MCU, the microcontroller unit. The pin default to input direction on, power up or reset. So pins are basically state high for the input, means the all pins act as a drain, means the voltage through this pin is seen to the ground. Now we can change the input output when we are programming of that system. So now we discuss about the port. So port C, B, C, D. Now starting from the port D. Port D consists of 8 pin. We called it PD027, and it acts as input and as well as the output. So the input output pin clubbed together we called IO pin. IO pin means input output pin. There are thousands of microcontrollers, so not go through the details about its architecture. When you program on a particular microcontroller, then you go through that architecture specifically. Otherwise, it's not required to memorize the all architecture. And one more thing is that the architecture of different microcontrollers, they are near about same because their structures and the operation styles are the same, and they are designed for different purposes, then their architectures are different. Means few portion of their architectures are different, otherwise all are same. So this is the another, okay, the same thing, timer, EPROM, serial port, serial communication, box expander, means that it able to uh, adapt the mode buses, then the mode controller, crystal, IO pin, reset pin, like that. So for pin data direction,